Insects were the first organisms to evolve active flight about 400 million years ago. If you look at a wing moving, it moves in a very complicated way, but actually a very small number of muscles is required because so much of the intelligence of the motion is sort of cooked into the mechanics.
The midsection of the fly is filled with power muscles, and they don't directly pull on the wing, but instead they deform the cuticle, the exoskeleton. And so these small deformations are transformed into wing motion by the wing hinge, and also these deformations are like amplified, so you get the long strokes of the wing back and forth.
The main question we set out to explore was how the wing hinge works as a mechanical structure.
Instead of trying to directly image what's going on in the wing hinge, we basically built a setup that can simultaneously image the activity of the steering muscles using genetically modified flies, which have their muscles fluoresce when they're active, and we can pick that up with a microscope.
The other technique we combined that with was high-speed videography. So we have 3 of the high-speed video cameras operating at 15,000 frames per second, capturing the full 3-dimensional motion of the wing. And in fact, Johan did a lot of work in machine vision just developing the system that you could take the data from those cameras and turn it into a quantitative measure of the motion of the wing.
It was quite a journey. It took me like almost 2 years to code the software to be able to do that, and it was essential for the project. But,
So that gives us our input and our output. The muscle activity going in, the wing motion going out, and then we used the techniques available in machine learning to correlate the two, to be able to predict wing motion from muscle activity, to come up with some very crisp working hypotheses for the roles of those 4 mechanical structures during flight. The technique required us to capture wing motion with an accuracy that we hadn't really imagined. And in order to create a rich data set where we had a lot of different patterns of activity, we really needed to have the animal in an obstacle course of sorts.
Once the fly is in the setup, we have a LED screen surrounding the fly, and this displays like natural patterns, and the fly can control the position of these patterns using its wings.
So imagine sort of putting a human on a treadmill and slowing the treadmill down, accelerating it, making it go backwards, and all the leg muscles would have to do a lot of complicated things. So it's a little bit the same for the fly in our large LED arena. The fly version of the wing hinge is very, very sophisticated. By studying other insects, such as mosquitoes, we think we can get a better picture on sort of what the ancestral state that the hinge was, which will not only be helpful in understanding the basic mechanics and function, but also will give us insight into how the structure evolved. Every time a fly hits their windshield or gets squashed under a fly swatter, there's just this marvelous little machine that's being destroyed.